Hi folks, in this video we review some arguments in our new system prop. So what I want to see is if you can evaluate all of these arguments correctly. Pause your videos and decide for each of these arguments whether it's valid or invalid. Okay, let's talk about the answers. There's two different techniques you could have used to try to figure out whether these are valid or not. You could have gone to the truth table technique. So for example, for argument A, you could do a joint truth table with the premise and the conclusion. It has 3 atomic sentences, so it would have 8 rows. And then you just check to see if any of the rows are counterexamples, if there's a line on which the premise is true and the conclusion is false. What you would discover if you do that is that the answer is no. There are no counterexamples. So it is valid, yes. The other technique you could have used is you could have tried to do a formal proof. Because if you can do a formal proof of it, you know it's valid. What that means is we would try to prove this arrow conclusion, and that would require assuming the antecedent in a subproof. You can probably see how the proof would go very easily just visualizing it. Because if I assume P and Q, I can then bring down the P with conjunction elim. Then I can use P and P arrow R, my premise, in order to get R. So it clearly follows from P and Q that R is true, as long as I know that premise. Now, you have to be careful if you're using the proof method, because if you can do a proof of it, you know it's valid. The trouble is, if you fail to do a proof of it, you cannot necessarily conclude it's invalid, because there might be two sources of the failure. Failure number one is because it actually is invalid. There is no possible proof. Failure number two might just be your imagination. There might be a proof and you just failed to find it. So it's not the argument's fault, maybe it's ours. So that's a good positive test, the proof method, but you have to be careful using it as a negative test. Of course, sometimes it's very obvious why you failed to do the proof. So if you can see that crystal clearly, then maybe you can still conclude safely that it's invalid. For example, what did you decide with B? Hopefully you assessed B as invalid. And if you try to do the proof of this, we can actually see why a proof is impossible. If all I know is P and Q arrow R, like for example, maybe I know that whenever Pia and Quinn both work together, Raquel has to be guilty as well. That doesn't allow me to conclude that whenever Pia is working, then Raquel has to be guilty. After all, maybe Raquel always works with Quinn, and that's why P and Q is sufficient for R. So if I tried to do a formal proof of this, I would assume P, and it would become very obvious to me that I can never just make up and Q out of thin air in order to use modus ponens on my premise. So the proof method can be helpful as long as you can see crystal clearly what's going on. You can always double check your answer by the truth table, because the truth table method is a perfect positive and negative test. Okay, what did you discover with C? Hopefully you assessed C as invalid too. If you do a truth table for this, you'll see that there's a counterexample, and it's also obvious why a proof fails. If I assume P in a subproof in order to prove this conclusion with an arrow, I'm going to be able to get Q by modus ponens, but I can't make up R out of thin air. So getting to the consequent is actually hopeless in that case too. The truth table will provide you the counterexample. Lastly, D is valid. So this completes our tour of argument review. Because after all, let's say I tried to do a proof of it and I assume P and try to get to Q. Well, then I could do modus ponens and get P conjunction R, and then I can get Q just by conjunction elim. So the proof of that is quite straightforward. So in this video, what we're doing is we're reviewing assessing arguments, and we're reviewing the two different techniques you have for assessing arguments, both the truth table method and some formal proofs. Okay, thanks.